Hi, welcome to my Databot channel. Today we're going to show you how to code an escape room style review game for your students. I call it Unlock the Databot. Today's theme is Disney movies, just because I thought that'd be fun. The idea is that you create a list of questions for your students, and they can swipe up, down, left, right instead of A, B, C, D. This is really super easy to actually make. I used ChatGPT to make this one. It took about 5 minutes, and it automatically even did the up, down, left, right thing, so I didn't have to try and format that. So it works really nicely. So here's how it works. Here's the questions. You have to have your Databot sitting in this orientation, the X at the bottom, and the Y on the left. And then you just answer your questions. In which movie would you find the character Mufasa? And the answer is Lion King, so you swipe left. And if you get it wrong, I'll show you the next one, it will turn red. But the idea is that they have to get through all the questions, and then it'll play a song. And then in mine, it also beeps out a lock combination so they can get a treat out of a treat bin. It also, if they get it wrong, here, I'll get one wrong. It'll do that. It'll turn red and then end the program. And then they have to turn the Databot off and then turn the Databot back on in order to start from scratch. Originally, I didn't do that, and I just let them advance. Whether they, if they got it wrong, they just could get the right one next, and it would let them go on. But the problem was kids are smart, and they would just quickly go left, right, up, down, and they could unlock the Databot in no time and not even read the review question. So I have it end the program, and I think that's a good thing to do. So I'll show you how to do that today. All right, let's get coding. You'll want to have a Databot turned on and connected. I like to start that way. And then make sure that your libraries are here. If not, you can always click Add Library, Kits and Boards, and click on Databot, and it'll add those basic libraries for you. Another thing you're going to want to do today is you're going to need to go up and turn this into advanced mode. Don't be alarmed by that. We're not doing anything too advanced. It just gives us more options. So click up here and make sure that this advanced button is clicked. If it's not clicked, it'll have less options to do. So advanced mode, there we go. All right, let's go in and test our gesture sensor and make sure it works. So we'll go with a when started program. We're going to use our light and gesture library. And there's two under that we're going to be needing. One is gesture available. This just gets the sensor ready. And then this one here, the last gesture, actually reads and stores that information. So whatever the last gesture was, it keeps that information. So we're going to need also a wait until command. And basically, we want the Databot to sit there and wait until there is a gesture available. And then once it is available, why don't we start off and just have it say what that is? Now, of course, that's not going to verbally say, in English, whatever that last gesture is. It's just going to print it up here at the top. And let's do that forever so that it will always say that whenever there's a gesture available. So let's test it out. I'm going to hit the play or the start button. And now if I gesture left, it should right up there at the top left. And if I go right, up or down, it reads that last gesture. Kind of cool. All right. Notice, by the way, that this is a lowercase, and that is important. It is case sensitive when we're doing the future stuff, and I'll show you later, but it is case sensitive. So it matters whether it's a capital or a lowercase letter. All right. So let's do some more useful work and check to see and turn lights on based on which gesture we do. I say we turn the green lights on for Databot if we swipe right, okay? So we're gonna need to check to see if our last gesture, I'm just gonna duplicate this in here, I could go get it out of the library over here, but is equal to right, R-I-G-H-T. And let's turn our lights on, green. Now I'm going to purposely have a little bug here. And I'll show you here. Oh, we need one more thing. We need a blue light. So we're going to have, when the Databot's sitting there waiting for us to answer a question, the blue light will let the user know that it's waiting to receive a gesture. Okay. And then when it sees right, it should turn green. Okay. Now it's not going to, because we're going to have a bug here, but here we go. Start the program, turns blue. Now, if I swipe right, nothing appeared to happen, although it didn't register that there was a right, up, down, right, but nothing happened. And the reason is it's checking to see if it's right and then turning it green and then coming right back up here and turning it blue. From our perspective as humans, that blue, green to blue, is instantaneous, basically. The computers are moving so fast that we're like in slow motion. We're like Barry Allen, and everybody, the computer is like Barry Allen, and we're like everyone else, just standing still because it's moving so fast. So we need to delay that program just a little bit so that it lets us in real time see what the light turned green, basically. So let's try it again. I'll hit the start button just to make sure. So this time, yes, now we're seeing that green light turn on. Our next step is to turn red if it's anything else other than right, because I think we should have a kind of a wrong answer, right? Correct? So this little button right here allows us to use an else. So this is an if this happens, if this is true, then this happens. Else, otherwise, basically, we want it to turn red. So I'm going to duplicate. I think I could have duplicated all, but I just wanted to make sure I didn't mess it up. And then we're going to turn it red. Let's make that a nice bright red. Okay, let's try it. Start. Now, if I swipe right, it should turn green, back to blue. If I swipe left, it should turn red, up or down, red. Great. Now, you could write a program and use a wait until every single time here, and just this would be your answers. I think that would be very clunky and not a great way to go about it. I have a more elegant solution in the form of lists. So let's try lists. To get your lists, you're going to start off with data. That's what we're working with. And we are going to make a list of answers. So this will be like your answer key. So instead of A, B, C, D, we can say left. Oops, I hit a space. Make sure there's no spaces. And then we can add more information. And right. Let's go up. And one more down. Okay. Now this list is not terribly useful at this point. We need to kind of give it a name and actually initialize it. So under variables, there's a way to start this off and create a list that is full of this information. So I'm going to name this list answers, just for convenience. And now when we start our program up here, and I'll put it in here, now it knows that this list is called answers, and that element 1, or the first slot in the list, is left, second is right, third is up, and fourth is down. All right, so now we need to go and actually, instead of just using a right command, checking for only right, what we want to do is check to see what that first answer is in our list answers. So let's go to data and see if we can find a handy tool here in the library. This is the one we're going to want to use. This is going to check for item 1 in the list of Rosa. Well, we don't have a list of Rosa, but we do have a list of answers. So we're going to click and drag this over here. Now we can put that in and check to see if this last gesture was item 1 in the list of answers. So we're going to check to see that it's left. It should be identical to what our program before was, except that instead of, we're not looking for right here, we're looking for this left. So let's try that. I'm going to click start. And if I go left, it should turn green. If I go right, it should turn red. That's because we're only ever checking element 1 in this list of answers. So we're only checking this slot. Well, anytime that we get this right, we want to move on and go to a new element in that list. So there's a little trick we can use, and I'm going to call it a pointer. I'm going to call the variable pointer, but this is how we're going to do it. We're going to make a variable called pointer. Oops, let's capitalize that just for, because I'm old. All right, now, instead of manually changing this every single time, we can actually create a variable that can represent and be changed easily every single time. So we're going to have this pointer. Instead of checking the number itself, we're going to check where the pointer is. And we always want to start off with our pointer starting at 1. If you put a 0 in there, it's going to give you an error because there is no 0 slot in this list. So we need to go to this slot 1 or element 1. Okay. So now nothing should change. It should still work. If I hit play, if I go left, it still is green. If I go right, it should go red. Because we're not manually changing, we're not changing that pointer ever. We're still only ever, we set it at 1 and it's staying at 1. But there's a handy little tool here called change pointer by 1, so that every single time that we get it right, we're going to add 1. And instead of it being, we get it correct, it's not going to be just sitting at 1. It's going to add 1 and it'll be at 2 the next time if we get it correct. So let's try this and see if it works. So I'm going to hit start, and it's going to need to go left, and the next one should be right, and then up, and then down. And so far so good, right? And we can kind of see, we can get some more information here. Why don't we add a little bit more information? Let's move our gesture so that we know that our what our pointer's at, and the gesture we just read. So I'm going to right click on there, duplicate, and put that in there. Now what it'll say is there'll be a number here, and that'll be the pointer location. So it'll start at 1, and then go to 2, and then go to 3, and as we go, it should give us the element location and the last gesture available. So let's try that again. So here we go. We should be able to go left, and that's sitting on 1. The next one should be, now we're sitting on 2 technically because I have it in the wrong spot, but 2, and it's indexing every single time. Up. Nope, did I get up? And then down. Yeah. Let's move that so that it's in a better location. And here's a cool little trick. You can right click on a block and say extract block. And we can put this at the end here. I think it'll give us a better number, a bit of information. So let's try that. Okay. Coding is a lot of trial and error in my experience, or at least in the way I do it. So let's try it again. So it should go left. Now it's on this correct slot. So now it's actually reading. The last answer was left. That's good. And now we're on slot 2, ready to read slot 2. So it should be right. Yep. And now it's on slot 3, should be reading up. Yep. And then down. And that's perfect. And that's it. Now, we are going to have an error at this point because we can't check to see if this last gesture is any of this thing, because now it's out of that range. Okay. So to do that, we're going to need a new element, a new if statement. And we're going to nest this if so that if, let's see, should we, yeah, we don't have to nest it. We can put it inside here. Now, what we're going to check to see is if the pointer gets past 4, correct, is what we're looking for, right? So we're going to go operator equals. We're going to need to check to see where that pointer is. So we're going to use the pointer. And if it's greater than 4, but we're starting on 1 already, so we actually need 1 more than the number of lists here. Instead of starting at 0, we're starting at 1, so we need to actually be 5. And I had to find that out the hard way when I was playing around. And so here we go. And this may need to be changed. We'll see how it goes. So if that's true, we're going to, what should we do? That's basically, we got to the end of the list, so that's the win, right? So how about we go, we'll turn it, I don't know what color is good, green, and then play a beep for the win. We could do more than that. I'll show you how later, but let's check this out and see if it actually works. And we probably want to, oh, maybe we make it a little more interesting. Let's actually make it go beep off and why don't we do that forever? It'll be really obnoxious, but that it'll do it. Or we can repeat it. Yeah, let's do it forever just for fun. Let's put this inside of a forever block. And this was not something we want to do forever, but just for the experiment of it. Oops, I'm going to zoom out a little bit because we lost some of our screen here. We're getting our code too big. All right, so let's try it. So now if I go left, right, up, down. Yeah, and there's the condition for victory, right? Oh, you can see I have that simple error again. I didn't have another wait after the Databot's lights turn off. And so it automatically just, we don't see it turn off. It's just automatically turning back on. It looks like to us. So let's do that again. Left, right, up, down. There we go. And that's the win. Now, you can make this list as long as you want now because it doesn't matter as far as you just add the 1 here. So if there was 5, you'd have 6. That's the only thing you'd have to change. And we could probably make that even better if you want. So it's automatically, you can just add as many of these as you want. So let's do that. I know in the data command, we have a place to check for length of our list. So I'm going to grab and duplicate the list. This should report about how many little elements there are in our block. And we want to always be 1 more than that. So we're going to go to operators and add 1. Come on now. And add 1. So now this automatically, we could have as many now answers here as we want. We can just add them. Let's repeat it so it's easy. Left, right, up, down. And let's try our game out. Let's zoom out again. So what's neat about that is it automatically knows we added stuff because we know we're checking our list length, and then we're adding 1 to that. Okay, here we go. Starting our game, and it should go left, right, up, down, left, right, up, down. Nice. And there's our victory. Now there's still one little bug. This is where I was saying we need to end our game if they get it wrong, because they could just do this really fast and up, down, left, right really fast and not actually read any of the questions. So if they get it wrong, what I added in there under control, we have stop this task. It might be others. Let's try this task and see if it's right. We'll turn them red, wait a half a second, and end the task. Actually, let's just end task right there. Yeah. Okay, so now if they get it wrong, it ended it when I went to the right. Let's try it one more time. Here we go. So if I go left, good, it likes that. But the next one, if I go up, errors out. And now if you look on my screen, it's the game, this thing is ended. To be able to start it again without being connected to the computer, I'd have to turn it off and then turn off the Databot and then turn it back on. So in here, I can just turn it back on. But we probably should create some sounds that are actually pleasing instead of this beeping stuff. That's pretty horrible. Let's do that. To get some different tones and different sounds, we can go to library and we can go to sound. Oh, tone, there it is. Tone. And now this will give us some more capabilities for playing notes and stuff. So here's I'm going to zoom in just a little bit. There we go. So we can play a specific note now for a certain length of time. So let's play a doot-doot sound. And let's go, maybe just go up an octave one. See what that sounds like. So if I get it right, I don't like that at all. Let's see. We can probably actually extract this block now that these are actually playing notes. I'm going to extract that block and get rid of that. Now that we're playing notes, we don't, because we're delaying it by playing a note. Let's go octave 1, octave 2. Let's see what that sounds like. Oops, I bumped the mic. Sorry about that. Let's try it. That's pretty good. Pretty good. Let's make it not so far apart. So let's change it from C to, let's go. Let's try that. Don't love that sound either. Let's try some more. Maybe just one note is what we want. B. This should be just. I like that. So B octave 1, C octave 2, and add 1 to the score. And then let's do the opposite of that if they get it wrong. Oops, got that backwards. Let's extract that block, put it back up there where it should be. And we can extract that block because we don't need it anymore because we are dealing with 1 full second of delay now. So, okay, let's try it. So left, that's kind of nice. And then if we get it wrong, we'll go up. And now they have to start it all over. And that's just about it. If you wanted to play a song, you could actually go online, find all the music notes and play a song. And instead of changing all of the, instead of having it turn green and black, you could have it play a song and then be done. And that would work. But this is your basic game. And if I start it from the beginning, let's see what she does. Oh, and we could, let's go for it. So left, right, left. Yeah, that's not annoying at all. And then this would tell you as the teacher that they finished the review. Anyway, I hope that helps. And if you need any help with it, feel free to hit me up in the comments. And I appreciate you. Have a good day.